This is the Horten Ho-229 jet fighter bomber. It was intended to be one of Germany's superweapons.
Nazi Germany built weapons that still fascinate historians, and one of the most ambitious was the Horten Ho 229. This experimental flying wingjet was decades ahead of its time, but its blueprints vanished in the chaos of World War II. Now, AI has reconstructed those lost designs, revealing details that left engineers and historians speechless. The jet's shape, power, and stealth features were far beyond anything the Allies faced, and seeing the plans today shows just how close history came to a very different outcome. The Horten Ho 229 has always been somewhere between aviation legend and technological myth. Even if this aircraft was made in the 1940s, it was unusual and futuristic, causing engineers to spend decades arguing over what it might have been capable of. Recent reports are revealing that a quantum-inspired AI system has taken that speculation and turned it into something more concrete. AI has reconstructed the aircraft's long-lost blueprints. The world is getting a brand new advanced aircraft that might just dominate the skies. Initially, scientists only had partial engineering drawings and notes, but nothing was complete. There was also an incomplete prototype sitting silently in the museum. That was the starting point for the AI. For 80 years, human researchers could only guess. With the chaos towards the end of the war, the Horten brothers couldn't keep the full details of the blueprints. The aircraft's production blueprints were scattered, misplaced, or destroyed during the collapse of Nazi Germany. But thanks to AI, it might not be lost. The AI started reconstructing with photogrammetry. Every angle of the surviving V3 prototype was scanned, mapped, and digitized in detail. The AI turned the aircraft's physical shape into mathematical data and even provided a 3D skeleton. The surviving documents included sketches in inconsistent styles, measurements that were inconsistent, and test reports from the V2's prototype. All of these were fed into the AI, and scientists waited to see what the result would be. Using a quantum-inspired generative model, the AI explored millions of design permutations in parallel. Instead of working linearly, it treated each piece of incomplete information as a puzzle. The system consisted of factors like aerodynamic laws, Germany's 1940s manufacturing limits, wartime material shortages, and the Horten's design style. Even methods of drag reduction and flying wing jets were added to the AI system. Every potential configuration had to fit the fragments of design we already had, but also produce performance that's consistent with what little historical testing data survives. At the end of the entire process, the AI produced something aviation historians once believed impossible. Experts now have the full digital blueprint set for the Ho 229, complete with the load-bearing numbers, panel geometry, and internal systems. But now that the aircraft blueprints have been obtained, there are many questions. Which countries will get this advanced design, as this was once captured by the Allied soldiers? What would have happened if the Germans had finished the design? And of course, what did the Germans expect from the Horten Ho 229 in the first place? In the waning years of the Second World War, Nazi Germany was chasing after even more ambitious aircraft designs. Among those designs, one of the major sensations was the Horten Ho 229. The story begins with the brothers Reimar Horten and Walter Horten. They were two German aviation pioneers whose earlier work on flying wing gliders had gained them a reputation for bending normal aerodynamics. As Germany scrambled for new weapons, the brothers were approached to make something unlike what they had ever made before. In 1943, the Reichsmarschall Hermann Göring demanded a bomber capable of the so-called 3 times 1,000 requirement. This means he wanted a bomber that could carry 1,000 kilograms of bombs, fly 1,000 kilometers, and cruise at 1,000 kilometers per hour. But no conventional airframe could meet any of these targets, which is why the Horten brothers came up with the idea of the Ho 220. It was meant to meet all these requirements because of its flying wing design, which was meant to offer low drag and high efficiency. The earlier designs of the brothers, like the H-4 glider and other tailless ones, also had minimal structural drag. They responded with their first design, which is the Horten H.9, later what we know as the Ho 229. It was a crazy and unexpected aircraft. It didn't have a separate fuselage or tail surfaces. Twin jet engines were buried in the wing roots, and it swept with flying wing geometry. But Germany was dealing with shortages of material during the war, so they could only make the plane with a steel tube in the center and plywood and laminated wood wings. Despite the urgency, the designers did their best to come up with a pliable design. On the 1st of March 1944, the unpowered glider prototype Ho 229V1 made its first flight. This was a preliminary testbed for control and handling. Then by December of the same year and into early 1945, the powered version Ho 229V2 joined the skies and was upgraded with twin Junker-Jumo 004 turbojet engines. The aircraft was way ahead of its time. The test pilots found it flyable, and the concept worked, even if the production versions were never used. With all the potential that the Ho 229 had to offer, Germany had a lot of plans to use it and gain the upper hand during the war. Nazi Germany was already under pressure during the Second World War as the Allied army had pushed it into a corner. The vision for the Horten Ho 229 was audacious and also desperate. The German planners imagined that the aircraft could dash through Allied air defenses with the speed of a fighter, yet carry a bomb load like a bomber. It was meant to strike deep into enemy territory, deliver its payload, and vanish before interception. This dual role meant that the Ho 229 was meant to be a high-speed fighter-bomber with surprise and agility at its core. Designed to counter the overwhelming Allied bomber offensives, the Ho 229 was meant to carry cannons and bombs in one package. Air Ministry documents show that the aircraft was to be fitted with heavy 30mm cannons, enabling it to confront bomber streams and also support a payload of up to 1,000 kilograms of bombs. German designers calculated that with twin-jet power and a pure flying wing layout, it could outpace any enemy it met and penetrate the defense zones of opponents. Production plans further confirm the intended scale of its deployment. At one point, a batch of about 100 aircraft was ordered, but it had to be reduced as the war situation worsened. But the Ho 229 wasn't meant to offer just speed and punch. The flying wing form was chosen because it reduced drag and increased efficiency. These are qualities essential for a plane that's tasked with both swift attack and range. Germany's bombing campaigns over Britain had shown the vulnerability of heavy conventional bombers, so what they needed was a fast, elusive weapon that could easily slip through defenses. Historians and experts reveal that the Ho 22 was designed to be a fighter bomber because the Germans knew that its speed was unsuitable for traditional bomber roles. It was meant for interception and rapid strike tasks. If Germans could have actually used the Ho 229 during World War II, they might have been able to make a major blow on the Allied countries. But it was never actually used in combat, and experts are looking into why. The Horten Ho 229 never saw combat, but it's not actually because it was a failed weapon. By the time the craft was ready for serious testing, Germany's war fortunes had already begun to collapse. The Luftwaffe no longer held the initiative. Their resources were stretched thin, and industrial production couldn't even happen because of the Allied bombing. The main priority was on weapons that could be mass-produced quickly. The Ho 229 was radical, experimental, and demanding, and could not fit into that immediate need. Production difficulties made it even worse for them to make the Ho 229. The brothers Reimar and Walter Horten had pioneered this flying wing jet, but they didn't have the large-scale manufacturing facilities required to make this work. The government could no longer wait, but handed the contract to build the aircraft to Gothaer Wagenfabrik, a company that was already affected by multiple bombings and stretched supply lines. In 1944, the Gotha factory suffered heavy damage. Production was disrupted, and critical material shortages started to affect them. There were also some technical issues. Flying wing configurations promised aerodynamic efficiency and high speed, yet they couldn't figure out stability and control challenges. The Ho 229 V2 prototype went on a test flight in February 1945, but it crashed and the pilot was killed. And let's not forget how dire the situation was in Germany. The supply situation was dire as their engines were poor, they didn't have materials and construction methods, and the Allied air attacks kept on destroying their factories. This made it hard for them to make their normal weapons and aircraft, and even harder to make their experimental platforms. After surrender, Allied forces captured the few remaining prototypes and documentation under efforts such as Operation Paperclip. The nearly complete V3 was seized in April 1945 and shipped to the US for examination. Some blueprints and components survived, but a full production variant never entered service or engaged in aerial combat. That raises the question, what might have happened if the Ho 229 had been deployed? Well, many historians believe that if the aircraft had been produced in numbers, it could have posed a serious threat to Allied bomber formations. With its high speed, flying wing aerodynamics, and potentially stealth-type features, it might have been allowed to evade interception and strike deep into Allied airspace. However, even in this what-if scenario, it's clear that Germany's overall war position was unviable. Making a couple of advanced jets could not have reversed the industrial might and air superiority that the Allies held by 1945. Germany couldn't have won just by making the Ho 229, but the country could have made a major blow on the Allied countries during the war. The Ho 229 failed to reach combat because despite how innovative it was, it couldn't compensate for Germany's failing logistics, broken production chains, and strategic collapse. Now, 8 decades after the war, scientists are finally figuring out how the Ho 229 could have worked if the Germans had been successful. Artificial intelligence has revealed different findings about the Ho 229. When the AI-based reconstruction system was applied to the surviving fragments of the Ho 229, with photogrammetric scans of the prototype, leftover blueprint fragments, test data, and manufacturing constraints, it identified that the aircraft's flying wing layout wasn't simply a bold aerodynamic experiment. It seems like they intentionally integrated multiple advanced design ideals. For instance, the system showed that the wing had a blended body shape, and there was no distinct fuselage or vertical tail. Also, the buried jet engines were within the wing. All of these contributed to a much lower drag coefficient and an unusually high predicted lift-to-drag ratio for its era. This means that the aircraft's efficiency was far higher than the previous estimates suggested. Instead, The AI flagged several features tied to radar signature reduction. It remains debated whether the designers were intentional in making a stealth aircraft, but the AI revealed that the use of wood and plywood in the wing surfaces, the smooth continuous wing body transitions, and the specific placement of engine exhausts all led to low radar reflections. If Germany had successfully made them, they could have become one of the first stealth aircraft. According to technical analysis performed by the Smithsonian Institution Conservation Team, Horten claimed to have planned a glue mixture containing sawdust and charcoal to absorb radar waves. The AI reconstruction, fed by material scan data and aerodynamic modeling, found that the structure of the wing, combined with the metallic internal frame and engines, led to a lower radar cross-section. The Ho 229 would have been comparable to conventional fighters of the time, but that doesn't mean it had a feature of near invisibility. For instance, radar signature tests of a reproduction indicated that the Ho 229 might have been visible at about 80% of the range of a standard Messerschmitt Bf-10-9. AI also flagged details that the human researchers might have overlooked or dismissed as secondary. It modeled structural load paths inside the wing and discovered patterns of reinforcement that were optimized for transonic flight stresses. It was something that wasn't found in the Horten brothers' notes or the wartime German records. The thickness in the wings was distributed from a 15% chord root down to about 8% at the tip, and internal spars were discovered by the AI. It suggested that the Germans already had an advanced understanding of load distribution for high-speed flight. This suggests that the Ho 229 wasn't simply a wartime novelty, but might have been pushing toward next-generation performance. The AI findings paint the Ho 229 as a machine that combines aero efficiency, material innovation, and low observability traits far ahead of its time. Even if the stealth credentials are less dramatic than often claimed, they came about as a byproduct of a carefully chosen flying wing layout, mixed material construction, and engine placement. Now the AI reconstruction is reframing the design as a new step towards a new type of technology that might dominate aviation today. The reconstruction of the Horten Ho 229 is now a major step towards the future of engineering, historical forensics, and modern modeling. Based on the surviving prototypes and fragmentary technical data, analysts and the findings from the AI estimate that this flying wing jet could realistically reach speeds around 950 kilometers per hour at sea level and even exceed 1,000 kilometers per hour at altitude. These numbers were not derived from speculation or propaganda, but from detailed aerodynamic modeling that aligns the aircraft's unusual layout and engine specs with wartime materials and constraints. The AI discovered that the steel tube center section, which is made with large plywood and laminated wood wings, delivered a drag profile that's much lower than that of a normal military fighter. The result was that the aircraft's flying wing geometry would have provided lift-to-drag ratios higher than many wartime designs, allowing predictions of extended range, strong climb performance, and high cruise speeds. But speed and efficiency are only a part of the story. The reconstruction revealed future-proofing built into the design. Internal structural reinforcements were identified that seemed over-engineered for just the prototype's configuration. It seems like the designer was eventually going to add more powerful engines, heavier armaments, and extended variants. AI also analyzed the wing's internal spars and bulkhead patterns and found out that the airframe was prepared for variants beyond what was ever built. Even more, there were other advanced concepts that you might not expect to see in an aircraft made in 1945. The designers were focused on high speed and carefully integrated jet propulsion into a blended wing space. It did so with an aerodynamic optimization of the engine inlet, internal ducting, and exhaust layout. The reconstructed performance envelope paints a machine that was strikingly advanced for its time. The Germans were making a single-seat fighter bomber that was capable of combining speed, stealth, adjacent construction, and adaptability. Many of the performance estimates, such as the climb rate, service ceiling near 16,000 meters, and range around 1,900 kilometers, were seen as overly optimistic. But according to the AI report and Reconstruction, these estimates are actually possible. The Ho 229 never flew in its full development form, but the Reconstruction offers engineers and historians a view of what it might have been. This aircraft could have had performance that matched or maybe even exceeded the early jet fighters. Now that AI has reconstructed the design of the Ho 229, experts have been shocked about what it could have been and even could be today. Many are wondering if the flying wing design can be advanced to fighter jets today and eventually dominate the skies. After the war ended, the only surviving prototype of the Horten Ho 229, the V3, was shipped to the United States, where it has become a rare artifact of aviation history. The prototype arrived under Allied control in 1945 and eventually entered the collection of the Smithsonian National Air and Space Museum. Today, it rests at the Stephen F. Udvar-Hazy Center near Washington, D.C., where it is undergoing careful preservation and conservation work. For decades, the Ho 229 V3 lay mostly forgotten in storage. Only in the 21st century did renewed interest rekindle scientific and historical scrutiny. Museum conservators documented signs on the airframe that suggest the jet engines may have been run at some point, as the scorched panels beneath the engine exhausts hint at actual engine operation, even if flight never followed. With the renewed attention and the results of modern reconstruction efforts, including advanced aerodynamics, material studies, and engineering simulations, the legacy of the Ho 229 takes on new meaning. The aircraft is no longer just a relic of failed ambition, but a precursor to modern stealth and flying wing concepts. Researchers, engineers, and historians increasingly regard its design as a spiritual ancestor to later stealth bombers such as the Northrop Grumman B-2 Spirit. Because of the AI-based reconstruction theories and renewed technical interest, the Ho 229 could now serve as a living blueprint, not for resurrecting wartime jets, but for understanding how early insight into aerodynamics, materials, and shape-based radar signature reduction converged long before modern stealth technology. Its smooth, blended wing profile, mixed steel and wood construction, and thoughtfully arranged internal structure stand as a record of 1940s experimentation that anticipated later developments. Now that AI has finally reconstructed the lost Horten Ho 229 blueprints from World War II, experts are wondering what this would mean for the future. Do you think this aircraft could be reconstructed for the military, or is it too outdated? Let us know your thoughts in the comments. So, thanks for watching this video, and we will see you in the next one.